All right, this is pre-calculus notes on section 6.5, Pythagorean identity. And here we're starting out with Pythagorean theorem, which you already know. And we're going to examine Pythagorean theorem and what relationships occur on the unit circle. So below that, I've got the unit circle. We discussed this already in section 6.4. For any triangle, let me draw a triangle here. There's a triangle. Right? Where the terminal side of theta intersects the unit circle, so therefore in this case the hypotenuse is 1, where r equals 1. Right? The coordinates of x and y, where terminal side of theta intersects the unit circle, are x equals the cosine of t and y equals the sine of t. So we're just going to substitute those expressions in for x and y. And here's what my new expression is going to look like. So I'm going to have the sine squared of t plus, whoops, I got this backwards. Sorry about that. Try again. Because x equals cosine. So we've got cosine squared of t, okay, plus sine squared of t equals 1 or 1 squared. It doesn't matter. All right. So this rule is true. All right. If the hypotenuse is 1, then cosine squared of t plus sine squared of t equals 1. It's a rule. It's always true. There it is again. Okay. Remember that addition is commutative, so you can write them in any order. So I just switched sine and cosine. Oh, one more thing. Let's take a look at how do you write sine. How do you write the expression sine squared? The one well-known other way to write that is to write sine squared of t. Okay, so these two things mean the same thing. You would take the value of the sine of t first and then square it. Okay, those two things equal each other. All right, so now let me move that out of the way. Okay. Now what I'm going to do is I'm going to use my other identities we've already learned to try and transform this Pythagorean identity into a new one. And so what I'm going to do is I'm going to divide the entire expression by the cosine squared of t. All right? And so there's a rule from algebra that says that any time I do the same thing to the left and right hand side of the sign, I get an equivalent equation. So by dividing by cosine squared of t, I'm not changing the value of this equation. Right? I'm going to break this down into terms. So I've got sine squared of t over cosine squared of t plus cosine squared of t over cosine squared of t equals 1 over cosine squared of t. And then I'm just going to rename each of these terms based on the identities that you learned in the first part of section 6.5. Right? So sine divided by cosine is tangent. Right? So this becomes, the first term becomes tangent squared of t. Anything divided by itself is 1, and so cosine squared divided by cosine squared is 1. Right? And then on the right-hand side of the equal sign, we've got a reciprocal identity for secant. 1 divided by cosine is secant. That's equal to secant squared of t. And then this new formula that we've just created is known as the second Pythagorean identity. We're going to go and do this one more time. First time I divided by cosine squared of t. This time I'm going to divide everything through by sine squared of t. sine, which is cosecant. So this is cosecant squared of t. Okay? So this is now the third Pythagorean identity. Okay? Here are all three of them. And if you like, you can write on the back of the treat card. Put it on the back of the treat card so that you can use it whenever you need it. All right, moving on. Here's some problems. Simplify the expression below. All right, so what I want to do is see if I can get one of these trig expressions to show up in this. That might help me simplify it. What I see is that in both of these two terms, I've got cosecant squared of t. So with all my factoring practice that I did earlier this year, I should think to myself, oh, wow, there's a GCF here. I wonder if that'll help me simplify. So let's GCF cosine squared of t. Okay, so I'm going to divide that out of both terms. All right, so the first term, tangent squared cosine squared divided by cosine squared leaves me tangent squared. Okay, well, maybe it would be helpful. Oops. Get this out of the way. Maybe it would be helpful if I showed all of this is being divided by cosine squared of t. Okay? So in the first term, I divided cosine squared of t out. I'm left with tangent squared of t. In the second term, cosine squared of t divided by cosine squared of t is 1. Okay? All right, so now let's take a look in my Pythagorean identities. Do I have anything that has tangent squared of t plus 1? I do. Yes, I do. So here, tangent squared of t equals secant squared of t. Let's put that in. So instead of tangent squared of t plus 1, I am going to write secant squared of t. So I've got cosine squared of t times secant squared of t. All right, and now what I had told you in the previous video, I can also simplify by rewriting in terms of sine and cosine. So this right here, I might want to try and rewrite that as using the reciprocal identity. So I've got cosine squared of t, right? That's the reciprocal of cosine there. So I'm going to write that as 1 over cosine squared of t. Okay. And so here what happens is this, we've got a common factor on top and bottom that cancels, and all of this is equal to 1. So this is my answer in simplest form right here, 1. This problem here is just like the previous one, and since I've got already 9 minutes on this video, I'm going to skip it. All right, let me think about this one. And again, there's lots of ways that you can approach this. What I think I want to do is, let me see if there's a Pythagorean identity that kind of looks like this. Let me look at my Pythagorean identities. There's a one that has both cosecant squared and cotangent squared in it. Okay, cosecant squared and cotangent squared. Look at this one. All right. But in my problem, I've got cosecant squared subtract cotangent squared. Well, can I manipulate this to look like the other? Let me just put this all on one screen. Okay. Okay, so I know I've got a Pythagorean identity that says 1 plus cotangent squared equals cosecant squared. Let me write that. 1 plus cotangent squared of t equals cosecant squared of t. Okay, so I want to get this to look like what's on the numerator of that fraction. All right, I want cosecant squared subtract cotangent squared. Well, if I were to subtract cotangent squared from both sides of the equal sign, I'll get what I'm looking for. Okay. So this is 1, bring down 1, equals, these cancel, and on the right I've got cosecant squared of t minus cotangent squared of t. Okay, so if cosecant squared minus cotangent squared equals 1, let's substitute our 1 there. Okay, and then 1 over sine is equal to cosecant. So there it is in simplest form. All right, that's it for that video.